Ready, set, go. All right, so I know folks are having a little bit of trouble with the ultrasonic thing, and there is kind of a catch. Like this isn't working exactly like a true version that we used in the classroom. That's got 3 pins, and there needs to be a kind of a call function to it. So there is a built-in one in there. You have to kind of see it. Like if you don't happen to stumble across it, I'm not sure you'd see like what it's actually doing. So what we're going to do here is I'm going to go up here again, and I'm going to start this one from scratch. Um, I'm going to ask you to maybe try to build it all out yourself too, because I'm going to show you the whole thing from start to finish, at least for just one light. And if you can go and make it be more lights or add something else to it, that would be amazing. But let's start off here just with, I'm going to start off by picking one of the basic starters for Arduino. And I'm just going to look for the one with the breadboard. So here I'm dragging it in, and I think I said this before, but if you can make it just be this is the only thing in your tab, and I guess the video window you're watching this in, it'll tend to run better if you're not running a whole bunch of tabs and other stuff. So here's what I'm going to do is I'm going to kind of drag this one down, and I'm going to first start off by adding in the ultrasonic sensor. So if I say just basic and scroll through my basics here, you'll notice that here's my ultrasonic sensor. So I'm going to now drag that one over, and I'm just going to place it here at the end. So you can see I've got them kind of all lined up right there. And because I'm in this end kind of slot here, this one's my ground one. I'm going to take this one and go to my ground line. I'll go here. And then this next one's my 5 volt, and I'll bring that down and do my 5 volt line. And then just because I want it to kind of look, the right colors for me and make sense, I can go ahead and change those colors to black and red to keep consistency. Now, if you really, really want to, you can actually click on these again, like double clicking will give you like a little option here to kind of line them up. If you want to be very neat about it, you can do that. By adding that extra little point, it kind of rounds it out, might make your design, your circuit board layout a little bit more cleanly. Now the next one we want to do here is we're going to actually have it connect all the way down from the one at the top all the way down to our AO pin. So you can do that either starting at the bottom, or you can start at the top to do it. Here I'm just going to get it that far to start off with, but you can zoom in and out. Here I'm just doing it with 2 fingers. I try to, yeah, not exactly what I wanted, but I'll click right there, and there's my line for that. And actually, maybe the green is a little bit easier to see. Let me drag this in, and I'll zoom in on it just a little bit so you can see what I did. I'm going to add in another bend point so we can kind of line this all up. And TinkerCAD does have a nice kind of alignment tool that's maybe a little bit better than what we were doing with the fritzing stuff. So here all I've done so far is I've wired this up. And if I click away, you can see here I've got my signal pin is in that line, and it's going to my A0, I should say, and my analog 0, and here I've got my 5 volt and my ground for it. So by just using these two, just trying to get it to show up in the code is where some folks were actually having trouble. So here I am clicking up there at the top on the code button, and if I were to kind of see if I can get this to kind of all maybe be nice, stay nice for us. What I have here by default is just it trying to highlight an LED, and I don't really want any of that one. So I'm going to go ahead and just toss all of that one in the garbage and start from scratch. What I need here is the ultrasonic sensor to work. And the ultrasonic sensor is what? Is it an input or output? And some people might argue that it's a little bit of an output and an input. And that's partly because it's sending out a sound signal, an ultrasonic one we can't hear, but it sends out a signal and then receives it. It's doing all this in this particular piece of hardware. The ping one with the 3 pins actually uses just 1 pin to do that. So this code for this one is kind of built into one of the blocks they've assigned. So this is where if we come in and take a look at what our options are, it says read ultrasonic sensor. So we know it's an input, and if we're trying to actually see that one, and maybe I can move me out of the way for a moment and get this window just to be a little bit bigger so we can kind of, sorry, lots of windows here. If I move these over, so maybe we can see this just a little bit better. You can see here it says read ultrasonic sensor. And the ultrasonic sensor here is looking for distance from the sensor on the trigger pin 0, which is not actually what we're using, right? We're using the A0 pin. And we're looking for the echo pin is the same as the trigger. And we're going to look for our value right here in centimeters, which is perfectly fine. We like centimeters. Now, if I were to take a moment here and back up and look at what the code says, if I go text, blocks and text, if I do that and then take a look at what code it gives us, and for some reason you can't really seem to make this much bigger, but if we look, what it's done here is it's added in an entire function for this. So you can see that now there is a read ultrasonic distance. It's using the same trigger pin and echo pin to be the same. It's doing sort of that quick micro, that little delay, and it's priming it and doing everything we need for it to do. So now we don't need to kind of really worry about what that one's doing. And we can just use that as a known value. Now, what I want to also have happen here is have some sort of output. So if I were to, let me switch back to just straight up blocks and try to make this all fit. Let me make this guy a little bit smaller and hide my code and maybe open it again. Sometimes that seems to help reset these windows, and not in this case, however. But what I'm looking to do is I really want to be able to say, have it give some sort of output on it. So I'm going to print to the serial monitor. And if I say just print to the serial monitor that value that's in there, you'll see it says do it with a new line. And if I ask it to do that, just that, and run this code, I can come down to the bottom and click where it says serial monitor, which I don't think you can see at the moment. Let's see, can I get this up a little more? There we go. So down here at the bottom, I can click serial monitor, and now it's showing that value. How do I change what that value is? Well, that's how I have to come over while it's running. See how it's it's actually running and giving me the value. Then I can click on the ultrasonic sensor and drag that thing around to adjust it. So if I click in here and I kind of move it, now you'll see the output is changing as I get closer and closer and closer. It kind of freaks out when you get too close. But this is really just like the ultrasonic sensor we use in the classroom, where it has a kind of set range. It would be nice if it continued to show you that where that ball kind of location is at any time, rather than when you click away from it, it disappearing. But we know right now that it's at that distance, that 227 centimeters according to it. Now, how do I make that? How do I turn that into a way of turning on a light or doing something else? Well, if I want to have all of that stuff show up, then I need some sort of conditional statement that says, you know, if you're closer to then a certain distance, then do something. And probably makes sense for us to have it turn off if it's a different sense or different distance. So if we're just doing a single one, we can say if it's less than a certain distance, else turn it off. So turn it on if it's really close, turn it off if it's moving away. So let's try that quickly. And you could do lots of if statements here, but if we're thinking about conditional statements here, what we're looking at is the control. So we're going to say, let's look at the control and say, what are my options? I have if, and I have an if and else. So from here, I could choose to do something like this. I could say if, let's see, I think I can use this one twice. That's a good question. Let me think. Well, let's do it this way. We'll start off with it just being a turn on the light kind of scenario. What I originally thought is I was like, wait, I need a distance kind of variable. And by having that distance variable, I can say, let's set whatever that distance variable is to what this is. Now, there's a weird kind of catch with this. When you run just this one and you get it, You'll notice right now that it's, here, I'll have it print out that. Let's hold off on my if statement for just a moment. Here I've got it so it says if, set the distance variable that I just made, set that to be equal to the ultrasonic distance that it's getting from the A0 pin. When it prints that out with a new line, it seems like, hey, that'll be great. It should do almost exactly the same thing as we're seeing right now. Except, notice really quickly here, I'm just going to play it for a second and then hopefully then stop it. What do you notice that's different down here in my sample? You'll notice that it's now just dropped off the decimal for it. And that's because all the variables that appears inside of here are going to then be integers. And I didn't realize this until I went to go look, and it's not a big deal, but you see here at the beginning of my code, it's saying, hey, let's make it be an integer. And since that's an integer at the very beginning, there's no way I'm going to get that. Every time I put a floating point into there, it's going to then just make it into an integer because it's an integer container. That variable is a container for an integer. So I'm not going to be able to get around that one, it looks like, unless I go straight complete code, which I haven't tried to do because there's no way to kind of go back. And then I'd have to write that whole function, which isn't bad, but we're trying to keep it simple at the moment. So here's what I end up doing. Let me go back to just straight up blocks. So I'm just going to say, forget maybe that distance, or if I do use that distance one, it's not a big deal because I don't really care about a fraction of a centimeter. Centimeters are pretty small anyway. So let's just do it without that. And I'm going to say, go back to my ifs, and I say, all right, if my distance is less than, I don't know, 100, then turn on the light. And if it's greater than 100 or not, if it's not less than that, then we'll just tell it to not do that. So, or turn the light off. So let's go to our math, and that's where we kind of have the comparison logic working. And what I'm going to do is I will pick, I guess it's any of these work, right? So what I'm going to do here is I'm going to pick this, and then I'm going to use my variable for distance since I'm setting it anyway. So if distance is less than 100, turn on a light. Now, I haven't wired a light up over here yet, but I do know how to do that. So I probably could just go ahead and tell it to set a pin right now. So I could say set pin, I don't know, let's make it pin 11, pin 12. Let's do pin 12. It'll be way up there. Let's set that pin 12 to high, and that should turn an LED on and just be great. And then if I want to turn it off, I turn it to low. So let me set it to low, set it to pin 12, otherwise it won't make any sense. And oops, let me leave that together. Just gonna click it all together so it all makes perfect sense. Now if I wanted to go look at my blocks code here, I could. I'm not gonna take that extra step at the moment. Let me zoom back out here. And here we go. So I need to just quickly put in a some way of putting in my my LED. I have to click the close the code button, and then I need to go over and find an LED in my space. So let me get me out of the way again. Whoops, not there, there. And let's find an LED here. So the LEDs I think are way up at the top in the basic section. I'm going to bring that over. And I think I'll keep it way over on the side here just to kind of line it up almost. And let me zoom in a little bit. Maybe a little bit more. And I'm just going to wire now. I'm going to forget the resistor. I mean, it's bad form if we were doing this in real hardware, but in the interest of time right now, I'm just going to go ahead. There's my power pin, pin 12 I said. Here's pin 12. This one is the other pin, right? And I've just added an extra line, which I don't need. I was just going to turn this one to black because we know it's ground then when we're kind of glancing at it. And so now when I run this, let's give it a run and see if I can get that light to come on when I do it. So I'm going to be moving the piece back and forth. So I go ahead and click start my simulation up there. And now remember, as it's playing, I got to click on my ping sensor, and we can see right now it's at 227 centimeters where our object is. As I move it in, and hopefully, there we go. Once we got under that 100, then it turned on. If I go past that, it fades out. Oddly, a little bit slow, but maybe that's just because I'm streaming everything at the same time. But here now I've got it working. So I've got it, so my sensor kind of pulls in and goes out. And you really could very easily now make it so that you had a way to maybe have all the lights kind of show your distance. You could have like a distance meter just with lights. So if you're far away, it would be all lit up. And then as you got closer, it would be down to like 1 or 2 lights when you got really close. And that'd be a really cool kind of application for it. It'd be kind of like your little distance detector for it. So that is what I was looking to see if you guys could manage to do. It wasn't as easy as I had hoped for it to happen. I think what we'll do is we'll play with this one, build this yourself, see if you can't make all the things I just did. And one more like quick, look at the code here. You can see it's not a whole lot of code. This like if distance is less than 100, and then just have it turn the light off, and then else if it's not, do that. If you're going to do multiple lights, which would be awesome, and I'll give you extra credit, then I would probably only use like, I would use a different structure for my if statements when I was doing it. If you wanted to add another line here to say what the value is, you could do that too. But if you want to also take a peek at what the code is at the end here, you can click on it and you can get a good idea for what it actually is printing out and writing. And it's not super complicated. It's not anything beyond what I think we've done in class. It's just kind of clunky as we kind of move around the space in here and do it. So I hope that answers your questions. Please shoot me an email with any questions you might have. And good luck. Wash your hands, cover your coughs, and don't do the drugs.